5.3, solving polynomial equations. This is not a very difficult section. You're going to be using stuff we've already learned to solve these things, and then go from there and graph them. All right. Notice I've got this nice pretty little thing. It has nothing to do with polynomial equations, but I just thought it was pretty, and I just wanted something different. I can change the colors, and I may end up doing it, but I just thought it was pretty. So just know that has nothing to do with what we're doing. It just, I liked it. All right, so when we're doing these, there are different ways to solve polynomials, okay? We did this last chapter. You factor out the GCF, the greatest common factor, okay? You take out what's in common, variables and letters, or combinations of both, to be able to get it down to where you can start factoring. You always want to do GCF first. That is the main thing. GCF first always. Then you can do check to see if it's a type 1 or type 2, depending on the coefficient of your quadratic term. You can factor it from there using the quadratic formula, which is really, really good. Or you can complete the square, or you can try to remember how to do master product. Either way, you can do that. Perfect square trinomials will break down. That's what we used a lot when we were doing complete the square. That's if you notice that this particular term is a perfect square and the back end is a perfect square, and when you factor it, it makes the middle. Got to watch those to make sure they do work, because there are some that look like perfect square trinomials but really are not. And then we have the difference of squares, difference meaning subtraction. That means that both of these are, it's a binomial, and it's with subtraction. And these are perfect squares, and these are perfect squares. And they always factor to the positive and negative of whatever you've got, the conjugates, okay? So be on the lookout, because you know we can't do, well, we can now. We can do a squared plus b squared, but that's not a difference of squares. That's going to be non-real answers we can solve now. And then, of course, factoring by grouping. That's when you have more than 3 terms, and you take the first 2 terms and you factor out what you can, take the second 2 terms, and hopefully that has the greatest common factor between the 2 of those, and then you finish that up. And the sum or difference of cubes. You definitely need to know those. These are the ones that we used. So for your signs, same sign, opposite sign, always positive, okay? You take the cube root of the first term, you take the cube root of the second term, the same sign, and then you square the first term, you square the back term, multiply the 2 in the middle together. We'll have to practice on those, because they're very, very easy to use when they give you sum or difference of cubes, okay? These are the different ways you can do it. Again, like I said, completing the square and quadratic formula. Anytime you have any weird answers with radicals and or imaginary answers with the eyes, I recommend strongly that you use the quadratic formula. You guys have gotten really, really good at that, and that seems to be something that works for you. All right, so when we're doing these, to solve them, you're going to write the equation and set it equal to 0. Okay, so everything's got to be on the left. Then you're going to factor it using one of these ways. And then you're going to use the zero product property to find the roots. In other words, after you factor it, you're going to take those factors and set them equal to 0 and solve it to find the roots. Okay? Very simple. That's all we've got on this particular thing. I've got lots of classwork for you to do, but this is just basically reminding you of the ways that we are going to be solving these and the options that you have. All of these options work for those quadratic equations that we've been working with. All right, so we'll practice a lot in class. I will see you then.